Hello, welcome to Program with Sam, and this is Python Lesson 2. Okay, so last time we looked at some data types, and we looked at the ones we had available to us in Python, as well as sort of control structures, functions, and just the overall indentation that we need to use in Python. So today we're going to be looking at NumPy and Pandas. Now, NumPy is a package that gives us access to something called NumPy arrays, and these are different from a list in regard to the amount of functions that they have with them. They're really more sort of like maths heavy. They give you sort of similar things that you can do to our matrices and vectors, like covariances, means, standard deviations of a NumPy array, and then the list goes on. Pandas, on the other hand, are more sort of data frame oriented, and they tend to be more for data analytics. So the whole structure of a panda is more akin to a table than a matrix. So it has column headers and row IDs, and then your data entries populate the table. So the first thing you're going to want to do is you're going to want to import NumPy. So import NumPy and import pandas. And that's really all you have to do to actually get the imports done. But one thing you will find is that a lot of places don't actually import them like that. What they do is they import as NP and import as PD. And what that means is it's essentially saying import NumPy as NP. So instead of using NumPy dot and then accessing the intricacies of the actual package like that, we'll be accessing it all through NP and PD for pandas. And that's really how you start, by importing them. The next step then is going to be to sort of actually use them. Now, NumPy essentially offers us a robust array schema with numerous functions available, including calculating mean, as we said, standard deviation, covariance, and it's good for sort of like multi-dimensional arrays. So we're going to have to maybe declare some to begin with. So what we'll do is we'll have a look and we will declare some NumPy arrays and then do some functions on them. So there are several ways that we can actually create NumPy arrays. One of them is going to be to sort of do, so let's say array1 is equal to, and we'll do np.array, and we'll put inside there an array of 2, 3, 5, 1, 2, and 7. That's one array. Let's say we have an array 2, and what we could do is we could fill this one with zeros. So np zeros, and all we have to do is specify the dimensions, and if we say, like, I don't know, like 2.6 or 2.8 or something, that should then populate an array of size 2 by 8 with zeros, funnily enough. Another function we can do is numpy.arrange. And what this will do is if we put a range in of, say, 25, it'll create a vector of size 0 to 25, or 0 to 24 technically. It'll just have 25 elements. We could also make it a float by specifying that the data type is a float. Or we could do within a certain range, so it, like with a certain step size. So if I did a range and I did 25, but I wanted to do from 25 to 26 with a step size of 0.1, that will create an array with 10-ish elements in it from 25 to 26 with a 0.1 interval. Array 5, what other things could we do? I mean, there's so many. There's line space, or linspace rather, indices. There's numerous ways of creating NumPy arrays. But just to show you how they're working, what I'll do is I'll print them out. Print array1, and if I just copy and paste this and just update the number at each iteration, we should be fine. So, like that. If we then give them a run, NP is not defined. Of course it's not. I didn't rerun that top block. There we go. So obviously you can see we have multi-dimensional array there, individual vector arrays there, and ones that have a step of 0.1. So now that we've examined how we actually create NumPys, we can index them, and we can access certain elements. So if we do array 1, and we're accessing index 1, that's going to give us 3. There we go, 3. But when it gets to a multi-dimensional array, what we can do is array 2. We can do 2, comma 2. Of course it is, because it's 1. There we go. So that's given us 0.0 because that's in this one here, 1, and it's at 0.2, which is here. So it's given us 0. If we wanted to slice an entire row, I believe we can do this. And that will just return the row at index 1. So because this vector here is, or this array here is index 1, that's what returns. It just returns the whole thing. And it makes it possible to even just return a slice of the row. So if we then do 4 or 5 even, it will return everything from 0.2 to 0.5. And that is how you index arrays in NumPy. So what I'll do is I will also include the different types. Sugar, honey, iced tea. We'll take this and we'll just include different ways of indexing, like so. And obviously the colon trick then also applies to the front half as well. And that's just how you index NumPy arrays. Next up, we have pandas. Now, pandas, as I said, are a lot more like table structures, but in reality, they're actually collections of series, which is essentially a list of values, and pandas just assigns a default integer index to them. So what we can do is we can say series is equal to pd.series, and we could then do mp.arange10. We run that, and then if we output series as well, that would be helpful. You can see that it's got the integer index that pandas has assigned it, as well as the actual value. So if I maybe did 10 to 15 with a 0.1 step, we would get something completely different. And that's generally the gist of a series. But then what about a data frame? Well, it's possible for us then to create a data frame using series if we so desire, or we can essentially create our own one. So let's do data frame is equal to pd.dataframe and then we want to give it a, maybe column A, or let's give the columns a name. Let's give it column name, and we'll just say that it's going to be, we'll just do a range 0 to 10 with a 0.1, and this goes on. We could then have b or like time is then equal to a range 15, and then we could have or wow, it'd be pd series, wasn't it? We'd have to say pd.series. So this is essentially building the data frame out of series. But what you will notice is that whereas before we were having one series with the index array, if we now run this and output the data frame, a range is not defined. np.arange is why. np, and we run it. It should then create one with name and time. And what we can even do here is just head, and that'll just return sort of like the top few in the actual table. There are numerous other ways to create pandas. So for instance, you could read in a file, and that's probably the most common way of doing it, is to read in like a CSV, because you're actually working with a data set. You're not generally going to be just creating arbitrary data sets like this, which have no relevance or meaning. Another way is that I think there's machine learning libraries on the internet which you can actually just load into pandas data frames using the link that they provide. And then that will allow you to actually tabulate your data before you actually process it. And pandas does have some data processing stuff, but you can also then convert your pandas to a NumPy array. So if we do NumPy is equal to, or if we call it array df is equal to data frame dot to underscore numpy. And then if we output array df, what you'll see is that now that data has been turned into a multi-dimensional array with a shit tons of nans. Now that's because the lengths of our two series are different. So here we're doing 0 to 10 in steps of 0.1, so you're getting a lot of those, but in there you only have 15, and that's where the nans have come from. So as it turns out, of course we don't need that. We index it exactly like we would anything else. Well, we can access individual columns just by naming the column. So there's too many brackets. And that'll just give us the name column. There we go. iloc for an individual row. It's a little bit fiddly, but to be honest, if you just Google it, like if you get stuck, chances are you're going to find the answer. There are a lot of people working with Python right now. It's a very popular language and it's rising in popularity with every passing day. It's one of those languages where there's so much on the internet because so many people are using it and working with it and helping each other use it, that if you get stuck, chances are there's already a solution on Stack Overflow waiting for you, which is quite nice. Another benefit of using a data frame is that you also have access to a function called describe. And this function will essentially give you the base level statistics for the columns in your data frame. Very, very useful, very, very handy. And in fact, I think R has something similar, and you can definitely do something similar in Nime. And that's about going to cover it for this one. Next time we're going to be looking at defining classes, classes and self, instantiating objects of those classes, and duck typing in Python. If you'd like to follow me at ProgramSamBlog or follow the blog itself at programwithsam.co.blog, that would be much appreciated, and I will see you in the next one.